Hi, everyone, and welcome to today's webinar organized by JetBrains. I'm Paul Everett, Python developer advocate. I'll be your host for a great webinar. We were joking behind scenes just a few minutes ago how every webinar is great. I say this every time. This one's going to be great. The topic for today's webinar is Ruff, faster Python linting with Rust. The word linting is like this, or like 57 other things that we're going to talk about today. Today's guest is Charlie Marsh, the creator of Ruff. Yes, Ruff, which has very quickly become a usable, powerful, fast linter used by important projects and a vehicle for new thinking. But what is Ruff? What isn't Ruff? Today we have Ruff's creator, the prolific Charlie Marsh. Charlie started as iOS and web developer at the Khan Academy. Yes, the one you're thinking of. Most recently, a staff software engineer at Spring Discovery doing interesting Rust plus Python plus ML platform work, and now currently working full-time on Ruff. Welcome, Charlie.
Thank you. Thanks so much for having me. I mean, you know this, but I'm a big PyCharm user and PyCharm fan. So it's very cool to be here, and I appreciate the opportunity to talk with you both and the audience about what.
We were also
what Ruff
talking about, by the way, a Talk Python episode with you interviewed recently, and I listened to that whole thing thinking, oh my gosh, we get to have him in like 3 weeks from now. Also joining my advocacy colleague, Vitaly Bragilevsky. Last time we hosted, Vitaly, it was JavaScript, but I think this topic of Rust might be a little more interesting for you.
Well, hi, Paul. I love all programming languages, but of course, Rust is a little bit more appealing to me. So thank you for having me here.
It's safe to say you cover the advocacy for our Rust plugin, right?
Yeah, that's true.
All right, great.
And everything around Rust.
Yep. As FYI, we did an interview with Charlie on the PyCharm blog recently. The answers are really intriguing. If you get a chance, go read it. Get us a little bit oriented, Charlie. What is Ruff and why does it matter?
So Ruff is what I call an extremely fast Python linter. It's a Python linter written in Rust that's designed to be extremely performant. So if you're familiar with other static analysis tools in the Python ecosystem, other linters like Flake8 or PyFlakes or PyCodeStyle or PyLint, there's a lot of tools out there. And these are all static analysis tools that look at your code and try to identify problems or potential problems. So Ruff fits into a similar category of tooling. So it looks at your source code, tries to identify issues, and tries to do so extremely quickly, hopefully. And unlike some of those other tools, although some tools do this, it will also try to fix a lot of those issues for you. So in addition to being a linter, it also does this sort of auto-fixing and code transformation process, which can really help speed up development and help you spend less time worrying about the things that you want to enforce in an automated way.
That's a good way to put it. I come from the front end world, and so a lot of this is happening. And in fact, I think you were inspired a little bit by the tooling going on in the front end world. Doug Farrell says over in chat, he agrees that the interview with you on Talk Python was great. He said that Talk Python interview made him switch a work project from PyLint to Ruff.
Oh, very cool. No, I appreciate it. Well, that was my first time ever on a podcast. So I guess this isn't a podcast, but I'm now a veteran, and hopefully this is even smoother. No, that was a lot of fun, and I appreciate that. Thanks.
Rust comes in, I think, tied with Python as most loved language. What is it about Rust in general or for this topic that you find compelling?
Yeah, totally. So it's interesting. Like I don't know if a year ago I really would have seen myself like becoming someone who wrote a lot of Rust code. Like I'm not like a quote unquote like systems programmer or anything like that. I've worked on a lot of different kinds of projects, but like most of my career has been in like JavaScript or TypeScript or Python, or some like Java and blah blah blah. But I've written almost no C, maybe like a little bit in college, and I don't think I've ever written a line of C++. And so like I don't think I'm like a supernatural fit to become like a huge Rust person, which is maybe like one of the bigger endorsements I can give for Rust itself is like if I can do it, like I think like a lot of people can learn and really like become productive with Rust. And the thing I would say about like working in Rust, having done a lot of Python, is it really like opens up the space of like things that you can build and like the characteristics of your program. Like I don't think like everything, I said this in the Q&A, like, I don't believe that all software should be written in Rust. But, if you want to build something that's, extremely, extremely performant, or satisfies some of these other characteristics, it's just very hard to do that in Python, for example. And so like learning Rust opens up this space of like solutions and software that you can build that would otherwise be somewhat inaccessible. And, I wouldn't say like it's really like not easy to learn Rust, in my opinion. Like I don't know, at least I found it challenging. Like you really have to think about problems like very, very differently. And I still think I don't even know that I would claim to be like a good Rust programmer, right? Like I think I'm like a productive Rust programmer and like I know how to work in the language. But for me, it's like I can now write software that I like otherwise wasn't really able to write and like felt really scary and inaccessible to me. And so that's part of why I love Rust, is like it, once I got into the right model, I felt like I could build like all these amazing things. And I think the community is really great. Like there are tons of really high quality crates, which are like the third-party libraries,
Sure.
like the things that you would install from PyPI. There's like a lot of people building like incredible open source stuff to leverage. It's once you get over some of the initial hurdles around like the borrow checker, it's just like really fun. There's a really fun language to work in.
Vitaly, you want to comment on two parts of that? One, the point about it's not that easy to get into, but also this idea that it's becoming tooling for other languages like JavaScript or Python or whatever. Do you want to comment on either one of those points?
Was that to me or to Vitaly?
To Vitaly.
Oh. Yeah, that's really the case for both communities. We have, I think we have many people who try to rewrite their tooling to Rust. But by the way, I want to ask Charlie, can you give us like several short reasons why choose Rust for your next project? Like, can you give us something like that?
Yeah. So I think I'll talk specifically, I guess, about Python, or some of this will be specific to Python. So one is like performance, right? Like it's definitely possible to write like really slow Rust programs. Like it's not like whatever you do in Rust is going to be super fast, but it does like change, I guess, like the ceiling or the floor, however you look at it, of like how fast your program can be and like the kinds of things that you could do that are just harder to do in a language like Python. I think for Python, the like Rust Python interoperability is really good. And that was actually my entry point to Rust. I was working at Spring and we had this big, at least by my standards, like Python monorepo, because we were doing all this scientific computing. And I spent a lot of time like trying to make parts of that fast, because like ultimately what I was responsible for was like building sort of the infrastructure and the developer tools that our like machine learning researchers and data scientists were using. And so I was trying to like make all those like libraries and tools really, really fast. And we spent time like optimizing some of that stuff in Python, but eventually we took some of those systems and moved them into Rust. And so, for example, like it's sort of a stupid example, but it had a really big impact. We had like a library that just downloads files from cloud storage as quickly as possible. And we were working with computer vision, so it was all like imaging data. So it's very, very common, like, thousands of times a day, right? We'd like download terabytes and terabytes of image data to like machines in the cloud. And the built-in Google libraries were really slow. And so we wrote like our own like Python thing that used like multiprocessing. And that was like faster, but we kept like running into bugs. And then eventually we actually moved that to Rust. So it was a Rust library whose sole responsibility was just like download files from cloud storage like really, really quickly. And in Python, you can, there's this really great tooling ecosystem around these libraries called like PyO3 and Maturin. And these let you take your Rust code and actually call it from Python, or take your Rust package and publish it to PyPI. That's actually what Ruff uses. So Ruff is written completely in Rust. There's actually like no Python. And we publish it to PyPI. And we do that through this tool called Maturin, which is part of that PyO3 ecosystem. So, we started doing this, and like more and more of our sort of low level, primitives, we like move them into Rust and would call them from Python. And that was like, to me, that was like, oh, this is like a superpower. We can like take this stuff and like move it into Rust. And then the callers, the people who are actually using those libraries, like have no idea that it's written in Rust and like don't have to even think about that. Like that's amazing. And that was a lot of the inspiration for Ruff. Is I was like, can I build a linter in Rust that from the user's perspective, like feels like it's written in Python? Like they don't need to have Rust installed. They don't need to know that it's not written in Python. So it's a very long way of saying that like the interoperability between Rust and Python specifically is really good. And so you can write, Ruff is not the only project that does this. You can write Rust code and make it feel like a Python tool or feel like a Python library, which is great for users, because I think if you had to install Rust to use Ruff, very few people would be using it. And so the ability to distribute like software that way, I think, is really powerful.
It's interesting. That was the original superpower of Python, was moving things to C. And it's interesting seeing a new generation of that, moving things to Rust. It's either, it might be Itamar. One of the Python oldsters has an article about, okay, you want to speed something up. Do you do it in C, Python, or Rust? And the conclusion is basically Rust. Do it for Python if it really is very little. And I guess Samuel Colvin is just a few months ahead of you on that same tool chain, converting things in Pydantic to Rust.
That's right.
So there is a bit of a trend for this. Now, look, real quick, so we can get to the demos, but you have a bigger vision for Ruff and your work than just linting, right?
Yeah. I mean, I'm always hesitant to like commit to stuff publicly, just because things take time, right? And like I don't want to create too much of a sense of expectations, but like, the dream for Ruff is really to have like an integrated tool chain, and for static analysis at least. And we've actually, like, maybe to give an example of what Ruff is today, like Ruff actually bundles a lot of functionality that is split today between lots of other tools. So, Ruff was originally modeled after Flake 8, which is another Python linter, and that has some built-in set of rules. But what we did over time is we started to take more and more of these other popular static analysis tools and actually just like build them into Ruff. And when I say build them into Ruff, I mean, like we actually just like rewrote big parts of them in Rust and like added them to the project. So, like PyDoc style, which checks doc strings, that's typically distributed as a separate tool, but Ruff actually just like implements all of that logic. PyUpgrade, iSort, like all these other tools Ruff can actually do like, pretty much what those tools can do.
It's interesting. So many of the tools do so many of the same things. What file changed on disk?
It's actually, yeah. So that's actually a funny thing, because like so much of, I think you'd be surprised like how much of Ruff's code is like finding the files to check, finding the configuration, resolving the right settings, telling the user like what happened, like giving user feedback. And like as we built out Ruff, we have all this like sort of like generic like linter or like static analysis infrastructure of like find all the Python files, like resolve the pyproject.toml files, like figure out what's a first party import versus what's a third party import. And so being able to like share all that infrastructure, it is actually like speeds up development a lot. And the other thing, I will answer your original question, but the other thing I like to point out about like the sort of like bundling of doing more things with one tool is that it's actually can be a lot more performant, because right now, if you're running like 5 or 6 disparate tools, they might all have to do like a bunch of repeated work that's hard for them to share. And so, for example, like if you're passing your Python files to like 5 different tools, and they're all reading the file, parsing the AST, the abstract syntax tree, traversing the AST, maybe they do their own like parsing logic. That's a lot of duplicated work. And so in Ruff, we parse the file one time, right? And then all of those tools like use that same representation, and we walk over the AST one time, and we, do the right checks in all the right places. So you can actually like share a lot of infrastructure, which both speeds up development, but also makes the tool much faster. And that to me has been like a big accelerant of like building more stuff into Ruff. Like it's not that hard for me to like add a new tool to Ruff, because we already have a lot of those abstractions built in.
Related, and keep it quick because we do need to get to the demo. But question, are you not worried about the maintenance cost of re-implementing all those rules?
I am. I mean, I think I would be wrong not to.
Sure.
But I do think that you get some leverage out of having like a common foundation. So like we have one abstraction for like figuring out if a variable is a what's the right way to say this? Like if we need to know if you have some variable and it's represents an import of a certain thing from a certain file, like this happens all the time. Like if we need to know if list is the list import from the typing module, and maybe it was imported under an alias, maybe the typing module was imported under an alias. There's like all these different ways that reference could be to list or not. We have like one way to do that, and like so many rules use it. And so we don't have to implement like import tracking like 5 or 10 times. We just do it once. Yeah. But the conclusion, just to answer your original question, and we'll move on. I want Ruff to become like an integrated linter, auto formatter, and potentially also a type checker, although that's the part that I admittedly know the least about. But I just think that like bundling this stuff together makes all the tools potentially like more performant and stronger. Like we have to worry about formatting in a bunch of places in Ruff anyway. And so integrating an auto formatter like actually makes that much easier. I think it kind of builds on the strengths of what we're already doing to like push in that direction. But all those things take time.
Sure. Okay, let's go ahead and jump into the slides. I'll go through them fast. Everybody wants you, not me. So with that in mind, we'd like to make this webinar as conversational as possible, as you can already tell. So if you have any questions, you'll see me looking over this way. That's where I'm looking at the chat. Go ahead and ask them. We'll answer them. And Charlie will take some breaks every now and then. At the first break, my wonderful colleague Vitaly will take the comments and questions for that one. So whatever you have, go ahead and ask them. Usually the first question is this being recorded? Yes, it's being recorded. It's YouTube. They record everything. So this will be available basically immediately right after the end of this. don't be the first one to ask, is this being recorded? Let's see. So that takes care of us getting situated. We're all set up with kind of the background information. Everybody wants to see a demo. Charlie, give us a walkthrough of Ruff.
Yeah, let's do it. So I want to like anchor this demo around an existing project. And I don't really have any like open source repos right now that are big enough to make Ruff like really interesting. So for the sake of picking something like sort of uncontroversial, we're going to use CPython. So we're going to look at using Ruff on the CPython code base. I actually tend to use CPython for kind of a lot of things. As the name suggests, like a lot of CPython is written in C, but by lines of code, it's about 2/3 Python, I think. And it contains a lot of like very diverse code. You can just imagine there's like a lot of different stuff going on. And so it tends to be a good code base for like testing and benchmarking and all that kind of stuff. This is the CPython code base. And here I just have my, my terminal on the right. We're mostly going to be using Ruff from the CLI, but we'll also look a little bit at using it within the editor, and I'll talk a little bit about at the end about sort of other ways to like install and use Ruff. So the first thing that we'll do is we'll just create a virtual environment, and we will install Ruff. Now I sort of talked about this before, but like this in itself is like a pretty cool thing, right? So this tool is like written in Rust, but I just installed it right with pip, and there was no like build step or anything. You can install Ruff, just with pip install Ruff, and we pre-build these what are called wheels and send them off to PyPI. So in almost all cases, you don't actually need to do anything; it just downloads that and sets it up. We have Ruff installed. Let me just move this around. So we have Ruff installed. Now, what's like the natural first thing to do? I would say read the docs, but that wouldn't really make for a great webinar. So instead, I think the first thing we'll do is we'll just run it. I guess like two observations from just running Ruff over all the code in CPython. So first, it completes in like, I don't know, a couple hundred milliseconds, which is very cool. But we have a lot of existing errors, right? We have 18,603 lint violations. Ruff is telling us that about 2,500 of them can be automatically fixed, but that leaves a lot of errors. So I want to start bringing that number down. But before we do that, let's try and make sense of like what Ruff is doing and why it's useful on a slightly smaller scale. So I'll just take this last file here, which is, I don't know, some file in CPython, and I'll just run Ruff over that file alone, and I'll open it up over here. So this is like some sort of WebAssembly build script that's included as part of CPython. And when we run Ruff over that file, it flags two potential issues. And it tells us where those issues are and a description of like what the violation is. So let's actually just like jump, I'm gonna close this. Let's actually just jump to that line 76. So we're looking at this error here, and it says on line 76, we have an F string without any placeholders. So if we look over here, that's this line. In Python, we have these sort of format strings, and they're designed to use these placeholder expressions where values get evaluated and inlined into the string. And here we have an F string that doesn't have any of those placeholder expressions. So it's equivalent to just removing that F prefix. That's the first error. The second, if we go down to line 601, is that we're binding this socket connection to a variable S that's not used. So this is equivalent to just actually like removing that binding entirely. Now this process that we went through of like talking through the code and trying to understand what the issues do or what the issues are, Ruff can actually help with that in like a couple interesting ways. So first of all, we actually ship like embedded documentation with Ruff. So here we have this F541 violation, which was the F string with no placeholders. I'll just jump back to that up here. If we ask Ruff to tell us about that rule, we actually ship with this sort of markdown-based documentation that tells you this is a rule that came from PyFlakes. It can always be automatically fixed. This is what the rule is. Here's some, I'll just make this bigger for now. Here's some explanation of like why it is a problem. And here's an example of what it looks like before and what it looks like after the fix. And also useful is that if we run Ruff with this show source option, it'll actually go through the process that we just went through of showing us the exact lines of code that are problematic. So this is this install native over here, and telling us how we might fix it. So those are useful, but of course, Ruff can also actually just fix the errors for us. So I just ran Ruff with the -- fix flag. And if we look at the diff, it removed that F prefix and it got rid of that variable binding.
I'm sorry for interrupting you, but I just had that moment everyone has. Like, did that actually run? It was so fast that you think it was like in dry run mode or something.
Yeah, no, it actually ran. Like I said, it fixed the 2 errors. So now if we run Ruff over that file, right, we're not getting any violations because the violations have been fixed. So that's like running Ruff over this one file and like looking at the errors and sort of understanding what they are and how we might want to fix them. But what we want to do, right, is run Ruff over this entire code base and get it to a point at which we can actually start like fixing errors and enforcing these rules as we add new code to the project. So the way that we're going to do that is through 2 strategies. So one is that we're going to use Ruff to automatically fix as many errors as we can. And 2, we're going to change Ruff's configuration to better match what we actually want to enforce and accommodate all the existing errors that we have in this project. So all of Ruff's configuration is done through toml files. So here I just created a pyproject.toml file. Ruff also supports a ruff.toml file if you're not using pyproject.toml, but this is sort of a very common way to express configuration for Python tools now. And a couple of cool things I like to point out about like, I don't know, like configuring tools is like an extremely boring topic, but I think that like Ruff does at least one very cool thing here, which PyCharm also handles really well, which is that we ship a schema for all of Ruff's configuration. And so if you open a pyproject.toml file, you know, in your PyCharm instance, and you type tool dot, Ruff will autocomplete. And that's not anything that I've done, like as the user of Ruff, to configure this. It's purely because we, as the creators of the tool, ship this schema, and PyCharm picks that up. So we actually get like auto completion and embedded documentation for all of the configuration options in Ruff, which is, I think, like extremely useful. We're going to rely on that a little bit here. So like I said, I haven't done anything special to configure PyCharm for this. It just picks this up. Poetry also does this a little bit. It's not that common. I wish it were more common. But we do have it for Ruff, which is really useful. So what I want to do is we're going to start like changing the configuration of Ruff a little bit. But to do that, let's actually just go back to, oh, sorry, I had a syntax error there. Let's actually go back to just running Ruff. And so, like I said, we have 18,600 errors. And if we just kind of look through, there's like a lot of repeated issues, and we might decide that like we actually just don't care that much about enforcing those rules for now. So let's go ahead and ignore them. So another way to look at this data is we have this -- statistics flag, which will tell us all the rules and how many violations we have in our existing code. So for example, we have like 3,500 line length violations where the lines of the code are too long. So let's just like ignore those for now. Oops, that's E501. We have a lot of violations around having like multiple statements on one line. Again, I'm just going to ignore those for now, just to, oops, what was it? E701. I'm just going to ignore those for now, just to like try to get the code into a good state, or try to get Ruff into a good state. So we're down to 13,000 errors from whatever we started with, which was a lot more than that. You know, if we look through, there's like a couple more things that we might want to ignore. So for example, like I'm just going to go ahead and ignore all the test files, which let's just say that we don't care about linting those for now. I also know in advance that there's a couple other things like this file here uses a bunch of sort of like magical global stuff. I'm just going to skip it for the purpose of the demo. And I'm just going to try and get Ruff. So now we're down to 2,700 errors, which is a lot more manageable. And let me just, for the purpose of time, ignore a couple more things. So I've reduced the errors a lot, sort of by cheating, by like turning off rules that we don't care about and ignoring files that we don't care about, which on the one hand is kind of cheating for a demo, but it's also like what you need to do is like tailor Ruff to your project, and especially when you're coming into like a big new project. A lot of what you need to do is figure out what settings make sense for you. But there are two tricks that we can use now to sort of get our code into a state where we can start enforcing rules. So the first is that we can just run -- fix over the entire project. So that fixed 495 errors. And if we look at what it changed, okay, a couple of examples. Here we had a dictionary where these keys were repeated. So it just removed the second key. This role variable was not being used anywhere. So Ruff just removed the assignment, et cetera, sort of inverting the orders of conditions to match PEP 8 standards, all that kind of stuff. Removing unused imports. So these are just rules that Ruff can fix on its own. The other, I'm just going to commit this. I don't know, whatever. I'm just going to commit this for the purpose of having a clean git diff, because the other thing that we can do now is let's just go ahead and actually tell Ruff to ignore all of those existing errors. I actually think this is like a really cool trick. So if we run Ruff with add no QA, what it'll do is it'll actually just add these ignore comments to all of the lines that had errors. That's really useful because now when we run Ruff, we don't have any errors, right? And over time, as we add new code, we will be required to enforce the rules because new code won't have these comments. And over time, we can actually like remove these comments as we go and change code and refactor. And so we now have Ruff in like a clean state, where from here we can start enforcing rules. We can start going through and like fixing these issues and like trying to understand which ones we care about.
Hey, Charlie, let's take a break there. That no QA thing is freaking magic.
It's cool, right?
Number of times I've wanted that.
The other thing that's cool is that Ruff can enforce that these comments are actually required. So if you add a no QA to a line that doesn't need it, Ruff will tell you that it's unnecessary. So Ruff can like add all this to your existing code, and then as you fix issues, it can also tell you actually that's not needed anymore, which I don't know, I think is like a pretty helpful workflow for a big new code base.
Okay, Vitaly is going to give some comments, and then I'm going to process a bunch of questions.
Okay.
Yeah, Hannah writes, now I want to check out Rust. That's great. I think that's what we're here for.
Ruff,
so Rust is
drug for Rust.
Yeah, so yeah, Charlie just promotes Rust in a very good way. So thank you very much.
Yeah, of course.
Yeah, and then people here are just happy about the speed of. So it's really great, and it's really just great, and we have several comments about that. And then also people say thanks, people like that, and people like WebAssembly. So
oh yeah. So we I guess one interesting thing that I can just pull this up because it's kind of cool.
No, hey, don't worry about it. We'll process and ask you them one at a time. For example, there was a comment from Pavilas who mentioned about plugin support. You have an opinion about plugins, don't you?
I do have an opinion about plugins. So right now, Ruff does not support plugins. And instead, what we've done is we've basically implemented plugins as part of Ruff that you can turn on and off. And I'll talk about some more of those in a second. I do eventually want Ruff to support plugins, but it introduces like some technical problems or some technical challenges rather. And it also, it sort of imposes some constraints on the project, because a nice thing about Ruff right now, and part of the reason that we're able to move, I think like pretty quickly, is that we don't have much of a public API. Mm-hmm. Like the public API is that command line interface that I've been using, but everything else like inside of Ruff, like we can change dramatically because there's no one else depending on it. And so if I want to change like the lint rule API or anything, or like the AST, like how the AST is modeled, like anything like that, like we can all change it in one place and like actually just do that refactoring in all the plugins. So like in some sense, or Ruff is still like early, right, as a project. And I do want it to have, it will have a stable public API that should include plugins. But for now, it's a little bit of an intentional thing to keep the project sort of hermetic in this way, where we can like really control like how it's being used, just because of some of the benefits it gives for us to like ship quickly and adapt as we learn about what
it's hard to
predict
need to
build
what
a linter
should be beforehand. You got to.
It is, yeah. I mean, actually, like I wanted to do plugins earlier. It's sort of funny, and like I started on this path of like building plugins into Ruff because it's pretty hard to do with Rust. And so I was like, okay, what's the first plugin I need to like make this usable for people? All right, I'll just implement it. And then, okay, wait, some people need this, I'll just implement it. And so, you know, what started as arguably as a bug, like has now become like a feature. And a lot of people, I actually find that like bundling resonates pretty strongly with people. Like there are a lot of people who are like, it's great that Ruff is fast, but like that's actually not important to me. And what's useful is like that I replace 10 tools with Ruff, and just the simplicity of learning one API, one tool, installing one thing.
Hey, before going to the next question, Vitaly, do you want to comment on Rust and plugins and Charlie's theory?
No. Please go ahead.
Okay, so I kind of know the answer to this, but I'll let you answer it. Eric asked, what's the rationale for integrating with Rust Python instead of CPython's AST module? I know there's a discussion in a ticket. What's your latest thinking? And explain the role of Rust Python in Ruff.
Yeah, that's great. So Rust Python is a really cool project. In some ways, it's like even like way more ambitious than Ruff, because what they're actually trying to do, or what they've done to, to a certain degree, is build a new Python interpreter and runtime in Rust. And so Rust Python isn't just like Ruff uses Rust Python's AST parser. So when we need to take Python source code and turn it into that tree of, okay, here's an import statement, here's a function call, we use the Rust Python parser, which takes the Python source code and gives us back this structured object that tells us what the program consists of. But Rust Python is more than that parser. Like in Rust Python, they use the parser and then they actually execute the code and like, you know, blah, blah, blah. And we just use the parser piece. I think there are like a couple of reasons why we use the Rust Python parser as opposed to the CPython parser. The first is that it's just the way I did it when I first implemented Ruff. And so that's what we do. The second, though, is that I think the technical integration is a lot easier because it's like we're just using another library as opposed to having to think about C to Rust, like the sort of foreign function interface of like calling between C and Rust. And the other is that it's a lot, like if you're working on Ruff and you're writing Rust, it's a lot easier to go and understand and like change the Rust code in Rust Python. And so we actually like contribute a lot of compatibility improvements to Rust Python. Like people who work on Ruff often will go and you know, send PRs on Rust Python. And so like having all the tooling in one language is really helpful. Now, if we use the CPython AST, that might, like, I don't imagine that we would need to change a lot of things, right? Because that's actually the reference implementation. But I think that like using one language ecosystem all the way down that stack is actually like pretty helpful. And it's cool to be able to like support Rust Python, and Rust Python supports Ruff and all that.
Let's go on to the next one. I provided a link to the ticket on it. I'll let you talk about it. When they saw you fixing things, they said, hey, this isn't linting, this is getting into Black's territory. So I linked to the ticket where you talk about how you feel about it, and then the Black and the Blue both came into the discussion about it. You want to just say a couple of sentences how you feel about that?
Yeah, totally. So so Ruff is always designed to be used. Ruff was designed to be used alongside Black, but it doesn't have to be. But we do, you know, the way that we implement auto fixing, we always try and do it in a way that's like compatible with Black. In most cases. I guess one like funny caveat there is Ruff can enforce quote styles, and Black almost always uses these double quote marks. But some people feel really strongly about like using single quote marks instead.
Hence
and so we actually, so we actually have a lint rule that's configurable around quote style. And so you could actually use Ruff to enforce and automatically change your project to use single quotes, which is something that Samuel Coleman asked for. But
just to wrap it up, you have an interest in trying to tackle some of formatting. Is that right?
Yes, absolutely. Sorry. I want, we're in the process of building an auto formatter, which will be integrated into Ruff. And there
was a
won't
PR
be like
today about it, right?
There are a bunch. I actually open sourced a bunch of the code last night, just completely coincidentally. I've been working on a private fork just while I kind of figured out some of the initial design and like played around with lots of dumb ideas. And now that I felt like it's sort of on a good path, I'm going to merge it all into Ruff soon. It'll be a while. Like it doesn't handle, I don't want people to get the wrong impression. There's a lot of things it doesn't handle.
Sure. And this is early days, so don't need to really give a status update on all that, but people can keep in mind that you can go to the repo and find information on this. Last little point, then we'll do a demo. We'll save up the other questions for the next segment. Some people asked, we're talking about PyCharm plugins and Kudai, who did the plugin for Pydantic back in the day. has a PyCharm plugin. You have a language server for VS Code. Someone was asking about Ale for Vim. Does that mean anything to you?
Like honestly, not really, but I'm pretty sure it is supported.
Okay.
Because yeah, the funny thing about working on like this kind of tooling is like you find out about all these editors and like editor integrations that you never use. Which is not to say they're not useful, but like, you know, I'd never used like the Helix editor before, for example.
Indeed.
Some people were like, hey, is there a way to integrate Ruff with Helix? And so then I found myself downloading Helix and like figuring out how to do that. Similarly, like I'm so hopeless with Vim and like NeoVim. It's like really embarrassing in a way. And I've had to spend a bunch of time like making sure that, you know, the plugins work because like different people want different tooling. So I think that is supported.
About it. It's fine to say not on your radar. So let's have you go ahead and proceed.
Yeah, we do. I mean, I will just shout out. We do. This was built by Kudai. So this is built by someone in the community. It's this Ruff PyCharm plugin. I use it. It's actually the thing that is giving me this error here. So like this is leveraging that Rust. That Rust extension, you know, highlighting that this is the error and that this is the way to fix it. So it's powered by Ruff and by that plugin, which is very cool.
One of the nice things about a PyCharm plugin is, unlike Black, where a daemon has to be managed, Ruff is so fast, you don't need a daemon.
Yeah. Well, hopefully it doesn't get to the point that it needs a daemon as we add more and more features.
Okay, let's get back to the
cool. So, you know, I guess what I wanted to do next is like, we now have the project in this like clean state. But up to this point, we've only been looking at the PyFlakes and PyCode style rules, which are also the ones that ship with Flake8, right? So all those rules with the F and the E prefix, that's all we've been enforcing on the project. And we've touched on this a couple of times now, but Ruff, like by design, actually ships with like all of these different plugins, you could call them. They're sort of plugins, they're sort of not, because they're like built directly into the tool. But all of these are implemented, like re-implemented in Rust as part of Ruff. But they are almost all inspired or based on the API of some other existing tool, which is why we use that terminology here. So for example, like the PyDoc style rules, right, are all prefixed with D. We have like the PyUpgrade rules, we implement iSort as part of Ruff, which is maybe a little surprising, but like, I think really cool. All these Flake8 plugins, blah, blah, blah. So what's happening here is it's just telling you, and this is all in the documentation has a much better like tabulation of all this, but these are all the different sort of sub-linters that Ruff implements, and these are the code. This is the prefix code for those rules. So Ruff isn't really designed, you know, or it's not, the expectation is not that like, I'm going to enable all of these rules on my project and I'm going to adhere to all of these rules. Some people actually use Ruff that way, which is totally fine. But like in my head, Ruff is kind of designed to be used in a little bit more of like an a la carte like manner. Like not every project, you know, is going to care about enforcing type annotations, right? And so if your project doesn't care about having all type annotations on all of your functions, then you probably shouldn't enable like the Flake8 annotations rule. And so I think part of like adopting Ruff is you can kind of look at what's supported, you know, and similarly, like you don't want to use the Django rules if you're not working in a Django app. So part of like working with Ruff is what rules do I want? I can add more over time, like what makes sense for my project. But it's really powerful because like you're not like learning any new tool, right? It's just the same API and it's just changing the flags. So for example, like if I wanted to, let's say I want to start enforcing import sorting on my project, I can just add this -- select I flag, and I'll run it with auto fixing, and it fixed 735 new errors, right? These are errors that didn't exist before because we weren't enforcing the rule. And if we look, right, it's now just like splitting up the imports and organizing them in a way that's like compatible with what ISOR would do. So in some
I'm
cases,
sorry.
it's
Can
moving it up.
you do a revert and rerun that with the time command in front? Because I want to see.
Oh, sure. Yeah.
That's just impossible.
I'll run it with no cache as well, just to make sure that there's no caching at all. So I think it was 224 milliseconds or something like that.
Yeah.
Sometimes I get confused with all this. It definitely wasn't 2 seconds, so I think it was this number.
I had a poll in the chat about it, got everybody to guess how many seconds it would take. And as I was typing seconds, I knew it was the wrong unit of measure.
But, you know, for me, like, I think this is a really cool model because like Flake8 Comprehensions is another interesting plugin. So this is, maybe it's actually just best demonstrated by example. So I just ran it. I just added enabled a bunch of new rules. It fixed 101 new violations. And if we look at what it did, so this plugin, again, it's like a little bit opinionated. So not every project should turn this on. But if you want to enforce this, it changes it from using the built-in invocation on a generator to just using a comprehension. You know, it can do this throughout your code base. And like part of the beauty of fast tooling is that you can just like do all this experimentation and like it costs you nothing. Like you can try out different rules, right? And like turn them on, turn them off, like see what changes, see what doesn't. And the key is that like you just have like a super fast iteration loop. And so I have sort of like idiosyncratic views about performance, but like that's one of the reasons that I think like developer tools especially should like really care about performance, because it's like it's the thing that you're running constantly, right? And it's like making a developer tool like 10% faster, the productivity that you gain for like all your other work, right? It just like really stacks up. And so you know, there's like stuff to learn with Ruff, and there's like a lot of rules, and like you have to figure out what you want. But like you can actually just iterate super quickly and like try things and throw things out. And it's part of what I want the experience of Ruff to feel like is like I'm never like sitting around waiting for Ruff to run. Like I can try the thing and it didn't work and I revert it, or I try the thing and I commit it, blah blah blah. There's a bunch more like I said, there's a lot more like I think very cool stuff in here. Like PyUpgrade is like a pretty amazing tool. And we implemented a lot of the rules that PyUpgrade enforces. So that can do things like automatically upgrading like your type annotations, or like, I don't know what else, upgrading your string formats. Like instead of using % formatting, it can automatically rewrite it to use like dot format calls or f strings and all that kind of stuff. So I hope that adopting Ruff feels like gaining access to like this huge tool belt of like gadgets, right? Or like superpowers, or like whatever analogy you want to use, where this list is like big and you can pick what makes sense for your project, but it's also like growing a lot. Like we just like we try to ship like pretty quickly and like implement a lot of new stuff. And so part of like, you know, adopting Ruff and like, and choosing to use it for your project is that you're gaining access to this like stream of improvements too. You know, not every rule will make sense for every project, but hopefully you'll find a bunch of things here that will help you write better Python code faster, I think is like the simplest way I could put it.
Want to take some more questions? Charlie?
By the way,
yeah, sure.
Do a pause for a...
Yeah, of course.
All right, so I'll Vitaly will start with a comment, but first, you mentioned PyUpgrade. That's Adam Johnson, right?
Flake8 Comprehensions is Adam Johnson. PyUpgrade is Anthony Satil.
Oh, that's right. Yes. Okay, sorry. All right.
I don't know if I'm pronouncing those names exactly correctly, because I never hear them said out loud. I only read them on the internet. So, but yeah.
Great tools. Okay, Vitaly, what do you have?
Yeah, with Rust, it's actually very easy to write slow programs. So it's not just granted for free. So and that's why I want to ask you, so was it really you just do nothing and it just runs fast, or maybe you're just very smart optimizing Rust programs, and it was like very, very hard job optimizing them, or just day 1, 0 seconds.
Yeah. So I think like, well, the first thing, which I cannot take any credit for, is that the parser is fast, and the parser, the Rust Python parser, and that's a good chunk of Ruff's total execution time, just parsing Python code, which I guess is good, because it means we're like not spending, like the rest of the stuff is fast, but the parser is very fast. I guess like a couple other things I think about when it comes to performance. One is like, I can't remember what the exact expression is, but with Rust, you can often have this like, is it like fearless concurrency or something? I can't remember how people put it, but basically like, it's just like really easy to like parallelize your code. And
so you use this asynchronous programming with async await calls and stuff like that?
We just use Rayon, which is a library for, so all we have to do right now, it's a pretty simple model. We just parallelize across files. Eventually, we're going to have to get a lot more fine-grained, but that's worked so far. So it's kind of like if in Python, right, you were multiprocessing and each file got its own task, or to process task, or whatever you want to call it. I guess the difference is like, I mean, I like Python a lot, right? Like I've written a lot of Python, but I always think that multiprocessing is really tricky. It's just very easy to get wrong. And I often find the performance characteristics to be very confusing. Like sometimes I use threads sometimes like threads are outperforming processes and I like don't really know why, or sometimes I want to multiprocess and now I have some object that's not pickable and I'm like stuck trying to understand all these issues. And I never really feel that way with Rust. Like I can kind of just parallelize, and like if the code compiles, like it works and it's like really fast. So like being able to parallelize like massively and not having to spend a lot of time thinking about it helps a lot. And then the other things, like it's a little low level, but like just trying to like avoid allocations everywhere that we can, and like really forcing myself to like not allocate new variables. So that was pretty hard to get right, but like we do very few allocations. I mean, ultimately with performance though, it's really just about like some of it's cultural. Like you decide in a project that like you really care about that performance is like really important. And so then whenever we ship a big new thing, I'm like always going to benchmark it. And that comes at a cost, but like, you know, I think it's worth it given the project, and that becomes a pattern that people actually care about. And I hinted at it, but the other thing is like, you just have to be like benchmarking a lot and like constantly, because I don't know, there's so many things where like,
I think you made benchmarking part of your CI, right?
It's not. No, I want to, but the benchmarks basically only exist on my machine. They're all tuned to my machine. But like, you know, there are things where it's like, oh, I read about some really cool thing that I could do that's like, in theory, should like speed the program up a lot, and then it like doesn't really make a difference because that part of the program is actually like not doing that much work. So even if it's 100 times faster, like you're not going to notice it at the end. And just caring about the things that happen a lot. So like parsing pyproject.toml files, like we could probably make that faster, but it doesn't happen that much. Like it happens at the start of the program, right? But like, I don't know, checking whether a variable is defined, that's something that we're going to do like a million times. And so you want to make sure that that's really fast, and that you're focusing on the right parts of the code.
It's interesting. You talked about some of these technical allocations. I think Samuel also did in his second wave with Pydantic and Rust, had some of those same questions, was asking Rust people, actually asked Vitaly to go and engage with them a little bit about that. And so it becomes an interesting pattern about performance.
Yeah. I mean, I think, there was a big learning curve with trying to get some of that stuff to work, right? Like there were certain Rust features that when I started learning Rust, I was like, I'm not actually going to really learn this part because I don't think I'll ever need it. Like lifetimes was the biggest example. If that doesn't mean anything to you, it's just a language feature where like you could kind of write a lot of Rust and like never use it. But like then depending on what you do, sometimes you really need it. And all of a sudden I like had to put lifetimes everywhere. So
okay, let's switch over to some questions. I promise people that even if we had to extend, we get to all the questions because these are all good questions. But treat them as speed round and go through them pretty fast.
Okay.
I think you already answered this one. Is it possible? This is from Juan. Is it possible to make rough sort packages like iSort does?
Yes. Yes,
excellent.
It is. I will do speed round, but I'll just quickly say, so by default, we implement something very, very similar to profile equals black, which is a setting that a lot of people use in iSort. And we support a lot of other settings, not all of them. iSort supports a lot of settings, but we've kind of added them as they've been requested. So you can get something quite close.
Ali asked a question. I think it's the same that I believe it was Eric was asking about the Rust, Python, AST, and pattern matching. Is there a roadmap for being able to parse around?
Oh, sorry. I just moved this onto the screen.
For being able to parse around Python modules with pattern matching.
So this is like the bane of my existence, this issue. There is, or is there a roadmap?
Let me put it this way. Is there a ticket people can go find?
There is a ticket, yes. Okay. And it is definitely the most requested thing in Ruff for good reason, which is, just to explain, Ruff supports almost all Python syntax, but the thing that it doesn't support, which people often run into, is the newish structural pattern matching feature. So in Python, you can write like, I don't know, match X, and then I can't remember the exact syntax, but Copilot's helping me complete it. So you can do this like, or that's not right. Anyway, you can do like this pattern matching thing. It's not important. It's not important the exact syntax for answering the question, but Ruff doesn't support that. There is a ticket.
Okay.
There's like a couple of different ways that it's being looked at. One is like a complete rewrite of the Rust Python parser that someone is making some progress on.
Did Black ever start supporting it?
Yes.
Yeah, Black supports it. To support it as well.
It did, and I might be wrong about this, but at least initially, there were certain forms of the pattern matching syntax that were not supported.
Yeah, right.
Because, and Black uses this lib2to3 port, which doesn't support pattern matching, and like Python moved to a new parser, and so Black has had to figure out like how do we add support for these other features that are hard to integrate into the parser, and they do support it. Yeah, so we definitely need.
Someone's asking about Ruff as a pre-commit hook.
Yes, so Ruff does exist as a pre-commit hook. It's in a separate repo. I don't know if my screen's still being shared.
Yep, that's fine.
Yeah. It exists as Ruff pre-commit. We have instructions here. These instructions are also in the Ruff README.
That actually brings up an interesting point. Early on, your interest in a lot of this Rust and speed was to run on the edge. Is that right?
Yeah, it was. I mean, I think WebAssembly is like really interesting, and you can do a lot of WebAssembly stuff with Python, and like the support's getting much better for sure. But Rust is kind of like a first-class WebAssembly citizen, and so I mean, one thing that we do is we just like continuously compile Ruff to WebAssembly, and we have this in-browser demo that's based on sorry, this is just like Ruff being compiled to WebAssembly and like used in the browser, which is really cool. And like sometimes people will like copy links and share them and for issues and stuff like that. But
as a tip for everybody, Pydantic also exists as wheels because of the Rustification.
Right.
So this is an interesting pattern. That's as WASM. I'm sorry, as WASM wheels. I mean, I left out the WASM.
Okay. Yeah. I was gonna say, I hope it exists as wheels.
Yeah. Okay. Newbie, I'm gonna let you have a quick treatment of this, but it's an interesting point. As a beginner, to Python, is Ruff a good fit, or would you encourage people to wait a bit?
So I think it is, but with some caveats. And the main caveat I'd add is that autofix, like the autofix API comes, like when you opt into that, you're like accepting some amount of risk and like liability, because automatically transforming code is like a hard problem. And it is definitely possible for Ruff to break your code by attempting to autofix. It is, I hope, very unlikely, right? And like getting unlikelier over time. Yeah. But like, you know, especially if you're using like more intricate Python features like locals or like, you know, magic stuff, like Ruff could break your code. And what we want to do over time is actually make it so you kind of opt into a level of risk, like really safe auto fixes versus like more risky auto fixes. And we're going to add support for that. But right now, if you enable rules and you auto fix, like we'll try to auto fix everything. And so, you know, I think in some cases that can be like a really helpful learning tool. Like you feel this a lot in Rust, where like the compiler and the linter often tell you how to fix problems and link you to issues. And that's like really, really
Vitali, you want to comment on that? Do you agree with that?
Absolutely.
Like
absolutely agree.
And you know, I think so on the one hand, like that's really helpful. Like the thing we did at the beginning where it tells you how to fix the problem, like I think that's really helpful. But on the other, you know, you might auto fix, and if you're new to Python, maybe you don't have like a big like test suite or CI setup or other things that will catch these problems for you. So that would be my main caveat.
That's interesting that not only the first reaction might be not ready for newbies yet, but with the like what it's similar to the work Pablo's doing with much better exceptions in Python, maybe Ruff could actually be fantastic for new programmers.
I think it's possible. I mean, I think like, you know, I like to be transparent about like the trade-offs that you're buying into when you adopt the tool. Like Ruff doesn't have to be for everyone. Like I'd like everyone to like using it, but like if it doesn't add value to people's projects or they're happy with their tool chain, then like that's great.
Hey, let's go on to the next one. Python PYX files.
Not on the roadmap, but it's something that has been asked about several times. So maybe it will become on the roadmap.
Yeah. Nuber asked about show Ruff with WASM. I believe we did. Nuber, if we didn't, follow up with another comment. Is there, if we were to enable more of the linters, this is from Kim, if we enable more of the linters, is there a potential for some of the rule violations to clash? This happens in the front end world. ESLint and Prettier are used together a lot. And there's 3 or 4 out of the box things where they conflict.
Yeah. So, like, I guess in theory, yes, but in practice, I think no. And we actually track in the code base incompatible rules. So like a good example here is like, there's a rule for like doc strings need to start on the first line, and then there's a rule for like doc strings need to start on the second line. And if you enable both of those, and they're both auto fixable, Ruff will just continuously try to fix back and forth up to 100 times, and then it gives you an error and tells you to file an issue on GitHub. But we encode that those rules are not compatible, and so if you try to enable both of them, it will turn one off, and it will tell you that you can't do that. So we have guardrails around that.
Yeah.
But
last question from Juan. He asks, Ruff's docs look really great. What'd you use for them?
Oh, wow. Thanks. They are MK docs with material.
Okay.
MK docs. Actually pretty new. Like we just had like a really long README on GitHub for a long time, which we still have. And that README is just translated into docs. So I hope people find them useful. Yeah.
Okay. If any of you have any more questions, go ahead and ask them. Charlie, do you have any more demos you want to do, or you want to get into
That's all I wanted to get through. Unless there's anything else that you want to see, Paul.
Let's go ahead and switch back to not slides, but switch back to us all on the screen at once to do a little before we get into the closeout. Charlie, do you want to talk about what you're doing in open source at all? What's it been like for you in this period? You had some things happen in your life that were really positive.
Oh yeah.
What's it been like during this period?
Yeah, it's just been like really crazy, but like very energizing. Let's see. Yeah, I became a father, so my son was born in October, and yeah, my son. So my son was born like 7 weeks early, so we were not like. There's nothing to make you feel unprepared, like having a baby like really early. And he spent like 8 weeks in the hospital, and that was right at the time. He's doing great, but that was right at the time that like Ruff was starting to take off. And so I was like hacking on Ruff in the morning and at night, and like in the cafeteria at the hospital, and like it was just like this amazing experience. Obviously very challenging in a lot of ways, but also this like amazing experience of like going through all of those things at the same time. And for open source, like I'm like really new to this. Like I've been a programmer, I wouldn't say like for a long time, but like, my whole career I've been a programmer, but I have not really been like that involved in open source. And so, especially not as a maintainer. So, there's been like a little bit of a learning curve. And I think there will continue to be I need to learn how to like say no to things, right? And like, but also while remaining like, I hope like really welcoming and like, and to anyone that comes with issues. I'm still trying to learn, and especially now that we have actual users, that comes with different responsibilities. So there's a lot to learn.
Will McGugan on last year talking about textual and getting focused on open source, and it's an interesting journey. Before we get into closeout, Vitaly, you got any comments you want to make?
Yeah, there are a couple of nice comments here in chat. Like I like this one. JetBrains was planning a 3 hours webinar, but after seeing how fast Ruff is, they reduced it to 2 hours. Right.
Best comment in webinar history.
That's great.
Yeah, so it was really impressive. And another, Eric wrote here, if all developers in the world are doing what Charlie is doing and being frugal, I can still use my iPhone 6s. That's right. I wanted to ask you, Charlie. So, would you recommend anyone learning yet another programming language? So, what do you think about that? Learning another and another and another programming language along the career.
I mean,
or maybe it's just okay to stick with one programming language and it's just fine.
So. I mean, everyone's welcome to have like an opinion on this. Obviously, I think like for me, I've tried not to couple like too much of my skill set and like identity to like any one ecosystem or programming language. And I think like at Khan Academy, we talked a lot about this idea of like T-shaped engineers, where it's like you should be deep in something, but it's good to have a wide skill set. And the part of the idea there is like expertise itself is like valuable. So if you're like really, really good at like Python or really, really good at Rust, that actually will have benefits when you go and learn another language, or like, just being trying to stay at like very much the beginner level and lots of tools is doesn't tend to create the same level of productivity. And so it's not really a good answer because I've kind of spent my career like trying to find my T, but I do like to like think of skill sets that way. Like I think it's good to, try to go deep on something and, spend time like working on problems. But it can also be really helpful. That skill set itself helps you learn new languages and enter new ecosystems. So I think it's really worth learning Rust.
there is an old joke that a real Fortran developer can write a program in Fortran in any programming language. So what about this? Can you see Pythonic traces in your Rust programs, maybe, or you just completely switch off?
No. I mean, one of my fears and also hopes is like someone who knows Rust much better than me, or people who know Rust much better than me, will come and look at the Ruff source and like tell me a bunch of things I'm doing that are not idiomatic, right? And are not, and like that has already happened a lot. And like I kid because like, yeah, it's a fear, but like it's also like an amazing part of open source, right? Is like people come and they're like, it's actually not, it's kind of weird to have a reference to an option. You should put the reference inside the option. Right. I'm like, oh, I'd never thought of it that way. So anyway, yeah, I'm sure I do things. There's things that's Pythonic and things that aren't idiomatic Rust, and I probably do some of both. And hopefully I'll get better over time.
You know, your point about T-shaped programmers, we have a lot of really strong advocates in that T-shaped thing at JetBrains. That T-shaped thing describes Vitaly probably the best out of all of us. I think of myself more as a Jenga tower. It's like got most of the pieces removed already and is wobbling around. I will use this as an excuse for a paid promotion. If any of you know anyone who's really good with the community and wants a great advocacy job, unfortunately, it would be working for me. We have a Python advocacy position open, so get in contact with me. Let's go ahead and head back to the slides and get Charlie out of here. Charlie, thanks so much for talking to us about faster tooling in Python. I mean, Ruff is an implementation of this idea, but you care as much about the idea, I think, as you do about Ruff specifically. What's the one takeaway point that you'd like folks to walk out with?
I think it's, I'll use this as a little bit of a plug for Ruff, even though I could have said something slightly more abstract. I think that like learning Ruff, like really part of the value here is like you learn this one API and then you get access to all these different improvements and like ways to enforce lint rules and fix your code. And my hope is that by like sort of buying into that, what I hope will become like an ecosystem is that you're learning this one thing and then you're getting access to like all these great tools. And hopefully the speed is something that appeals to you a lot, but I think there are also other great reasons to use Ruff, and I hope some of those came across.
Yeah, well said. All right, let's go ahead and wrap up. If you'd like more information on PyCharm, Python, Ruff, Rust, whatever, please go to our website at jetbrains.com/PyCharm. I should probably point you over to Vitaly. We've got other parts of the website that cover our Rust activities. Lots going on there. Check out our PyCharm blog for news and announcements for releases and events. Newsflash, we're making a lot of releases. Things are going to start picking up in the next few weeks. In addition to educational resources such as this webinar, which probably is going to have 4 trillion hits once the algorithm picks it up. We'd love your feedback after the webinar. We read it, we look at it, we talk about it. So please feel free to contact us on Twitter or in the after webinar survey. If you did register, you'll get that. Send it in. Tell us what you think. Tell us what you want us to talk about next. We'll send that email around in a little bit. That is all for us today. Thank you very much for joining us and hope you have a nice rest of the day.